Hello, Chapter 5, Strategic Capacity Management. In this chapter, we'll take a look at explaining what capacity management is and why it's strategically important. We'll also exemplify how to plan for capacity and also evaluate capacity alternatives using decision trees and compare capacity planning in services to capacity planning in manufacturing. Let's get started. We take a look at the Tesla manufacturing capacity for the Model 3. Tesla received more than 350,000 pre-orders for its Model 3 sedan. Maximum past production was 50,000 cars per year. Tesla will need to raise its capacity to 500,000 per year to meet demand. Has already raised lots of funds from sale of stock, bonds from the founder, etc. And Tesla builds these cars in Fremont, California and Shanghai, China, and is also building a plant in Berlin, Germany. Capacity management and operations and supply chain management. Let's define our terms here. Capacity is the ability to hold, receive, store, or accommodate. In business, viewed as the amount of output that a system is capable of achieving over a specific period of time. Capacity management obviously needs to consider both the inputs and the outputs, and many industries measure and report capacity in terms of output. Industries whose product mix is very uncertain, like hospitals, often express capacity in terms of inputs. In that case, it would be number of beds. Capacity planning time durations. Generally, longer range is greater than 1 year. There's also intermediate range, monthly or quarterly plans covering the next 6 to 18 months. And then there's also short range, less than 1 month. Finding the overall level of capacity intensive resources that best supports the company's long-range competitive strategy, facilities, equipment, and labor force size. Capacity level selected has a critical impact on response rate, its cost structure, its inventory policies, and its management and staff support requirements. If it's too low and the firm loses customers, it encourages competitors. If it's too high, firm may have to cut costs or underutilize its workforce. It's like I refer to it as the Goldilocks principle in the sense that it has to get it just right. Capacity planning concepts. We have capacity best operating level, capacity utilization rate, economies of scale, and diseconomies of scale. Also capacity focus factory, capacity flexibility, and plant within a plant, PWP. In capacity flexibility, you have flexible plants, ability to quickly adapt to change, zero changeover time, flexible processes, flexible manufacturing systems, simple, easy setup equipment, and flexible workers, ability to switch from one kind of task to another quickly, and multiple skills. These staff should have multiple skills so that they can be cross-trained. Remember, cars change. Automobile manufacturers change cars every year, so they have to shut down assembly and modify and change their manufacturing processes to handle a brand new product. Considerations in changing capacity. Well, you have to maintain system balance. And how do you do that? Well, similar capacities are desired at each operation, and also you manage bottleneck operations. What are bottlenecks? Ask me that question in class and we'll talk about it. Frequency of capacity additions. The cost of upgrading too frequently and the cost of upgrading too infrequently. Two problems. You can always tell when a company is, deficient in its upgrading of its facilities. And you can go in and you can see many times companies don't even upgrade their air conditioning. You go to a mall. I know there's a Sears by my house, and I go in there, I start sneezing immediately because I know that there's mold in the air conditioning because I'm very sensitive to that, and they haven't upgraded or spent any money on that. You ever go to a company and you go in the bathroom and it looks like it's a third world country in there. These are companies that have ignored these kind of deferred maintenance, if you will, and it usually means that they don't have the money for it. That, I think, is a warning sign to take a look at when a company can't afford to do their maintenance and keep things in good shape. Next, we have frequent versus infrequent capacity expansions. I'm not going to go through this one. You don't need to know that, but for forecasting, you have to determine capacity requirements. And we use forecasting to predict sales for individual products, calculate labor and equipment requirements to meet the forecast, and project labor and equipment availability over the planning horizon. If you are a manufacturer and you are manufacturing multiple products, you have to figure out what you're going to sell possibly a year or more in advance, and you have to anticipate, and then you have to backtrack, and you have to make sure that you have all those parts, you have all the money, and then you have the labor in which to put together these parts so that you can sell the product. Example 5.1, determining capacity requirements. Stewart Company produces 2 brands of salad dressing, Paul's and Newman's. Each is available in bottles and single-serving bags. They have 3 machines that can package 150,000 bottles each year, and each machine requires 2 operators. They have 5 machines that can package 250,000 plastic bags per year, and each machine requires 3 operators. What are the capacity and labor requirements for the next 5 years? Well, we can chart that out. In year 1 through year 5, we have Paul's Choice. We saw the rules and said how many bottles we could do. 60,000, 100, 150, 200, 250 plastic bags. It's in the 100,000s. And Newman Select. And what can we do with this after this? Well, we can calculate the equipment and labor requirements to meet the product line forecasts. And we figure it out this way with the bottling operation and with the bagging. And we can take all of this information that we have here and put together a master production schedule. Put it all together, project equipment and labor availabilities over the planning horizon. The planning horizon is 1, 2, 3, 4, 5 years in advance. And we can see percent machine capacity utilized. Very low here in the first year or 2, and then it's rising. Remember, we can't use equipment to 100% capacity. Why can't we do that? We'll answer that question in class. And then you have the similar information here where it's ramping up very nicely. But you can't run things at 100% capacity because, well, they get tired, they burn out, and then you have to replace the equipment. And with all of this planning here, you have to also anticipate that this equipment is going to burn out or become obsolescent or effectively not be able to be used. So you have to plug in those costs, replacement costs, so that you'll have the money when that happens. If we use a decision tree to evaluate capacity alternatives, it's basically a schematic model of the sequence of steps in a problem, including the conditions and consequences of each step that you take. Why do we use them? Well, decision trees help analysts understand the problem and assist identifying the best solution. Decision trees components include the following. You have decision nodes, represented with squares, chance nodes, represented with circles, and the paths that link the nodes. Work from the end of the tree backwards to the start of the tree and calculated expected values at each step. So we take a look at a decision tree. Hackers Computer Store, evaluating 3 options: expand at current site, expand to a new site, or do nothing. The decision process includes the following assumptions and conditions. Strong growth has a 55% probability. New site is 210K. Payoff, strong growth, 195,000. Weak growth, 115,000. Expanding current site is 87,000 in either year 1 or 2. And the payoffs is strong, 190,000, and the weak growth is 100,000. Do nothing, strong growth, 170,000, weak growth, 105. And here's the details of each of the value of each alternative. The value, move to location, 765. Move to new location, weak growth. Expand store, strong growth. Expand store, weak growth. So we have the up, the top and the bottom, top and the bottom, and top and the bottom. Do nothing now, strong growth, do not expand next. Which is the most valuable one that you have here? It looks like expand the store with strong growth. Diagram of the problem chronologically. You have Hacker's Computer Store. Here's the options: move, expand, or do nothing. And then the strong and the weak, strong and the weak, strong and the weak, and the probability of each one of these. And then you have the revenue minus move is the cost. And then we can plug in those numbers and we can see how cost effective it is and which one makes sense. Which one makes sense? We'll talk about that in class. Planning service capacity. Well, manufacturing capacity is different. Why? Well, goods can be stored for later use. Can you store service capacity? Can you inventory service capacity? No, you can't. In manufacturing capacity, goods can be shipped to other locations, and volatility of demand is relatively low. Service capacity, the capacity must be available when the service is needed. It cannot be stored. Service must be available at customer demand point, and it's much higher volatility than is typical. Capacity utilization and service quality. The relationship between service capacity utilization and service quality is critical. The arrival date, the average number of customers that come to a facility during a specific period of time. Service rate, the average number of customers that can be processed over the same period of time. Best operating point is near 70%. Optimal levels of utilization are context specific. What do we mean by that? Well, low rates are appropriate when the degree of uncertainty in demand is high and the stakes are high. Emergency room, fire department, etc. Higher rates are possible for predictable services or those without extensive customer contact, for instance, commuter trains or postal sorting. I'm going to skip this one, and then I'm just going to summarize what we have. An operations supply chain management view of capacity emphasizes the time dimension of capacity: long range, intermediate range, and short range. Best operating level is the rate that is sustainable by the system. With economies of scale, as volume increases, average cost per unit drops. Focused manufacturing plants is designed to produce multiple products using a concept called plant within a plant. And from a strategic long-term view, capacity additions or reductions come in chunks. And the last of it, a useful technique for analyzing capacity problems is the decision tree. With this format, the sequences of decisions are organized like branches in a tree. The potential consequences of these decisions are enumerated based on their probability of occurrence and corresponding expected value. Often, services require that capacity be available immediately and that it be near where the customer resides. Firms that offer services often need to deal with dramatic changes in customer demand over time. Thank you.